You're now the presenter, Steven. Welcome,
Great.
everyone, to Back and Relax.
Hello, everyone. My name is Steven Feuerstein. I am an Oracle Developer Advocate for PL SQL. This is a new organization I'm leading called Oracle Developer Advocates. And the idea here is that we're not only advocating for our technology to our user community, but we're advocating for our users back into Oracle to help tune our products to meet your needs better. So feel free to let me know what you think of this presentation, what you think of PL SQL, how you think it should be improved, PL SQL, SQL, whatever else. There's my email address. Follow me on Twitter, please. I need my numbers to go up. Check out my blog, and I have got a new YouTube channel called Practically Perfect PL SQL, and you'll be seeing lots of videos coming out that way. But today I'm going to talk about PL SQL anti-patterns, and the plan is that I'm going to talk through 4 different of these so-called anti-patterns, which I will explain in just a moment. But after each one, I'll stop, we'll open up the lines, we'll have some discussion if there is any, and then we'll move on to the next, so you're not just sitting there for 40-something minutes waiting for me to finish talking, because chances are—
real quick, don't forget to share your screen.
Thank you. Chances are I will never finish talking, but I will share my screen. So now I have to go back and say, there you go, there's my title.
PC.
We're good now? Yes. Email address, Twitter, et cetera, et cetera. My apologies for that. Okay, screen is shared. The title of the talk, PL SQL Anti-Patterns. Let's dive in. Of course, we must start with the safe harbor statement, which hopefully I will never actually have to use, because I don't want to talk about any potential future products. I want to talk about PL SQL in the here and now, how you can utilize it more effectively. In pretty much all of my presentations, I'll be making references and running files with PL SQL inside of them. You have access to all of my files at the PL SQL Learning Library, oracle.com/OLL for Oracle Learning Library/PLSQL. Take a quick look there. You'll see my lovely face, one of my P3 Practically Perfect PL SQL videos. If you drill down, or zoom down, scroll down, I should say, click on Demo Zip, you can then download my zip file with all of the scripts that I've got. And I think it's extremely important, not only when you're just learning new technologies, but when you want to take somebody's advice, to validate that advice. Don't just trust it because we told you. Don't trust it because I say it. Don't trust it because Tom Kite says it. Test it out for yourselves, and we provide the scripts to help you do that. Okay, so let's talk about patterns generally, and then we'll dive into anti-patterns. So hopefully you're aware, but the world around us is absolutely full of patterns, because the natural world, the thing that we, and the laws that it so-called follows, though the natural world doesn't follow laws, we just come up with the laws in our heads. Anyway, they're all the exact opposite of chaos. It's all about patterns, consistency, and predictability. And it turns out, partly because when you write software, what you're really doing is writing a sort of little world unto our own. Software is also full of patterns. And I'm sure you've had the same feeling of me of deja vu coding. Haven't I seen this code somewhere before? Didn't I write a piece of code just like this last week? Now, I think it's actually quite critical that we come to understand the role of patterns in our lives generally and in software, because once you can identify patterns, first of all, you can say, is that a good pattern or a bad pattern? If it's a good pattern, you want to do more of it. If it's a bad pattern, you want to avoid it. And this, again, is true not only for software, which we'll focus on exclusively for the next half hour or so, but also in the world. And to give you a sense of some of the background on this whole idea of design patterns in software and the role of patterns in software, I encourage you to check out these 2 links. First of all, Christopher Alexander. Christopher Alexander is an architect. In other words, he designs houses, buildings, and so forth, who really originated the idea of a pattern language in the world around us and in the way that we build things in the world. And he's got some amazing insights about how to construct things to make it a higher quality experience for us in the world and for the world itself as well. And I encourage you to check out his books and his writings. But most interestingly, his writings about architecture in the real world, in the natural world, had an enormous impact in the world of software. So he basically spawned an entire new area of research and development called design patterns, and you can find out more about that in Wikipedia. And the idea behind design patterns is exactly that. Most of the code you write follows a fairly predictable or at least repetitive pattern. I'm writing a cursor for loop to iterate through the rows in my table. I'm writing a case statement to do X, Y, Z. And so people have actually built entire books of patterns, and the idea here is that you lock into a pattern. You say, oh, this is my MVC pattern, my model view controller pattern, and here's the implementation of that pattern in a generic sort of way, and then you follow that design pattern, and you reach higher quality code more quickly. But there's also some other aspect of patterns, and those are the bad patterns, the so-called anti-patterns. And the anti-patterns are things that we all too commonly do that result in suboptimal code. And the idea around anti-patterns is that when you can recognize one in an existing piece of code or as you're writing a new piece of code, you can then say, whoa, that's right. I don't want to write code like this. What I should do instead is X. Here's the resolution of that anti-pattern into the positive pattern. So what I thought I would do today is talk about some common anti-patterns in PLSQL. So first up, what's the problem? So here's a block of code that declares a variable, full name. It's declared to be varchar210, and I assign a value to it. And then at the bottom of my block of code, I've got an exception that says if anything goes wrong, trap that error, log it displayed, et cetera, et cetera. So what's the problem with this code? Now, just to keep you real busy, Jeff, could you unmute the lines now, and we'll see if anybody's got a thought about what the problem is with this sort of code?
Line should be live.
Thank you, Jeff. So if you were looking at this piece of code, doing a code review, which I'm sure you all do on a biweekly or monthly basis, do you have any concerns?
Variable length.
The variable length. So what's wrong with the variable length?
Too short.
It's too short. Okay, so let's get right to the heart of it. Thanks, and Jeff, you can mute the lines again. So the reason that caller said that the length of this variable is too short is that he could tell at a glance that my name, which has a lot of E's, it has almost 10 E's all by itself, is too long to fit into that varchar210 variable. So this will cause an error. Now, there are a number of problems and anti-patterns in this code. One of them is that I've hard-coded my declaration and made it too small. The second critical one is that I've got an exception section here that says if anything goes wrong, I trap the error. And you can see from the way I wrote this code that I'm sort of thinking that it will trap the error that will get raised when I write this code or when I run this code. And the fact is, as I'm sure many of you know, that will not happen. An exception section in a PL/SQL block can only possibly handle an exception that was raised in the executable section of the block. But if it's raised in the declaration section, the entire block closes down. The exception goes out unhandled to the outside block. So take a look at this piece of code. It's a little bit different. What's the problem? I won't go back and unmute the lines because the problem is still basically the same. I've declared a varchar210 variable. I've hard-coded the length, which means if this full name function returns a string, and that's too big, it'll blow up this entire procedure, and it will not trap the exception locally. Now, the reason I wanted to point out these two different pieces of code is that in the first case, I could eyeball the code and say, well, that's kind of ridiculous. Why would you do that? In the second, it's not so easy to see that there will be an error. In fact, there may not be an error most of the time. So since the value is hidden away behind this function call, it makes it less clear as to what will happen when I run the code, and therefore introduces more uncertainty. So the anti-pattern, fundamentally, is assigning a default value to a variable in the declaration section with an expectation that that exception could be handled locally. What's the solution? Well, to my mind, when it comes to assigning values to literals, when it comes to the assignment of literal values, by which I mean, back one more, this kind of code, so I'm assigning a literal value directly. When it comes to that kind of code, my suggestion is you take responsibility for reading your code. In other words, sure, we could talk about revamping that code. We could talk about taking different approaches that I'll come to next. But the main thing is read your code. Don't just rely on the compiler. Don't rely on quote-unquote testing, which means try your code and see what happens. That's good, and it's important to do all those things, of course, but the most important thing is to get in the habit of actually reading your code and asking yourself, what's going to happen when this runs? Code works on logic. It works on a lot of stuff, but fundamentally it works on logic. Software or computers do what we tell them to do. So we should be able to read our code and logically know in advance what it's going to do. The second thing I suggest you do is use compile time warnings. This is a feature built into PLSQL that will basically have Oracle do some of the work for you in evaluating your code and analyzing it and figuring out how to improve it. And I'll show you what I mean by that in just a moment. Now, so that's when it comes to with the assignment of literals. But then there's this other situation where I've got an assignment of a function. In this case, I can't eyeball the code and say, well, that could be a problem, or that's never going to be a problem because the value is hidden away, and therefore, obviously, we can't trust that it will never be a problem. But eyeballing the code doesn't do it. So what do we need to do there? Well, in general, I would suggest that when your default value is an expression or a function call, in other words, if it's something that's not a literal that you can look at and say, that's going to work or not work, then move the assignment into the executable section and invoke it from its own initialization nested subprogram. Here's the idea. So now I've got a declaration of my full name variable, and I've hard-coded it to varchar210, which is a problem all by itself that I'm not really addressing in my little session today. But notice I don't assign a value to it in the declaration section. Instead, in my executable section, I call my initialize procedure. Now, PL/SQL doesn't in and of itself offer an initialization section in blocks of code. The only place you can talk about initialization sections are in packages. So you essentially have to do it yourself, and you can do it yourself, and I suggest it as a general practice. Create a procedure. Inside your procedure, this is called a nested subprogram, and it's one of the most critical features that Oracle offers to write maintainable, highly readable code. And then put inside your initialization procedure all the startup code, checking the values of parameters, making sure that none of your assumptions are invalid, and so on and so forth, assigning all the values to your variables. And then simply call that procedure in your executable section. Now, as a result of doing that, if this raises an exception, if the value coming back has more than 10 characters and blows up my constraint, then the exception section in your procedure can handle it. You could even move your exception section into your initialization section. You could have separate exception sections for each one. But in any case, because I've moved the assignment into the executable section, I can trap it right there. The other nice thing I like about this approach, and it could have been the same if I had taken this and put it directly, everything I just told you about trapping the exception would have been the same if I put the full name directly in my executable section. But the reason I like to put it in a nested subprogram is that when I'm looking at my main body of code, I want to focus on the core algorithm that I'm implementing for, in this case, process employee. All the initialization steps, all the cleanup steps, they're important, and I need to have them there, but I'd rather not have them clutter up my view of the core algorithm. So by creating this procedure initialize and hiding the logic there, it all goes away and is replaced by this single statement. When I need to look at it, I can go into that procedure. But usually I will not need to look at it, and I can focus on the main algorithm. So that's why I really like the idea of using these nested subprograms. Okay, now let's go back to this piece of code right here. In fact, I'm going to get really lazy, and I'm going to grab the code and move it into SQL Developer. And I'm going to connect. Okay, so first of all, I'm going to create or replace procedure, test it. So there's my procedure. It's now going to compile. I'm sure of it. Let's try it. So the procedure compiled without any trouble whatsoever, no errors. But yet we can look at this code and we can say, come on, you've got to be kidding me. That's a really problematic piece of code. Okay, well, that's true. And let's ask Oracle to help us with that instead of us having to eyeball it ourselves. So I'm going to go to my demo zip directory. And you'll see here a lot of PLW files. Again, you have access to all of this code. PLW stands for PL/SQL warnings. So one thing that you get from using an Oracle database with 10G or higher, and hopefully you're all on that, is that you have access to this great new feature in the PL/SQL compiler called PL/SQL compile time warnings. What I'm going to do is enable all the warnings. Great, so my session has been altered. Now, I'm going to compile my code again. Now I get some very different information. Let's look at that again. Whoop, compiler log. Now it's giving me very interesting information. So first of all, it gives me 4 warnings, 2 of them the same. So one of them is PLW 5018, and what it's saying is, Steven, you really should include an auth ID clause in your program definition. Auth ID says, do you want it to be definer rights or invoker rights? I don't have time to get into the details here, but the default is definer. Most of us don't put an auth ID clause on our procedures because we don't need them, but it's always good to be explicit. So let's actually compile again. Great, now I'm down to 3 warnings. Now the most interesting one from the standpoint of what I was just talking about for anti-patterns is the 6017, an operation will raise an exception. So what it's saying is, Steven, you've got a problem, and it should tell me line 3. So on line 3, when you run this procedure, you're going to get an error on this line. Now, it doesn't actually tell me which specific error. It'd be nice if it did, but that's not as important as saying, look at that line of code, Steven. And what it's saying here is that, essentially, your string value is detected to be too large for this container. So Oracle actually tells me that. Really nice. Then it gives me 2 other warnings. By the way, lines 5 and line 7 are both unreachable code. This is kind of interesting. It's a trivial example and not that useful for you. But what it's saying is this line of code is never going to execute. And you might say to yourself, whoa, that's crazy. Never going to execute? How could that be? It's the first line. Because the declaration section is going to fail. So one of the things that compile time warnings also gives you is automatic unreachability analysis. For large programs, you might run this analysis and find that there's a whole section of your application that never executes, theoretically impossible to execute, and it can be very hard to find that sort of stuff out. Okay, so let's get back to it. So again, to sum up, when it comes to assigning values to your variables in your declaration section, if they're literals, fine, leave the literal code there because you want them tightly connected, visibly connected, but read your code and make sure it makes sense. Use compile time warnings to indicate when you've got a problem or have Oracle do the heavy lifting for you. But when your default value is an expression or function call, use that initialization section. Create your own initialization section, essentially. Okay. What's the problem, Jeff? Would you unmute the lines, please?
They may be unmuted already.
Oh. Okay.
I think.
It looked like a speaker was just speaking, but I couldn't hear them. Can you try it again? Would anyone like to try speaking now?
A whole lot of returns.
There we go. Sorry, so a lot of returns? Yep. Anything else besides a lot of returns? Okay, let's take a look. So that's true. There are a lot of returns, and that's the core anti-pattern to look for. There's a hidden bug, or not so hidden, related to those multiple returns. So Jeff, feel free to remute. Let's go to the PLW 5005 file. So here's my program function no return. Now it's probably going to be pretty clear what's going on, but let's enable warnings. Create my function, my 2 little helper functions. And then I'm going to create this function. Now before I look at the log, what I'd like to do is actually try it out. So I'm going to call my function, pass it false. Let's see what happens. And I get an error. I get a really embarrassing error. 6503, function returned without value. I'm not sure if you've ever seen this error in production. If you do, it's got to be personally embarrassing to you, right? I wrote this function so poorly and tested it even worse or inadequately so that the function doesn't even execute a return statement. Wow, embarrassing. Now the good news is that Oracle will tell you this. So if we look at my compiler log, right here I can see PLW 5005, subprogram no return returns with that value at line 21. So this is a situation where Oracle has automatically taken a look at my function and gone through all the different pathways and said, wait a minute, you return here, you return here, you return here, but oh, look at that. There's no return on that else clause, and there's no return at the bottom. So Oracle has, at compile time, given me a warning that, Steven, under some circumstances, you might end up with that 6503 function return with that value error. Okay, so what do you do about it? Back to the anti-pattern. The fundamental anti-pattern here is too many returns, and because I've got all these returns, it makes it possible that I've got a point at which I exit without a return. So here's the basic idea, and it comes from structured programming from years and years and years ago. There should be one way in and one way out of your procedures and functions, etc. So multiple returns in your executable section make it likely that there will be a way out that does not call return. And the basic idea that you should take is that in a function, there should be just one return statement in the executable section. There could even be one in an exception handler, depending on the exception. But make the very last statement in your function the return statement. And use compile time warnings to let you know about the problem. Now, I think I just had a question on the chat. Can the PL/SQL warnings be set to enable all by default in SQL Developer? Jeff, I don't actually know the answer to that question. Do you? Can we actually set up SQL Developer that whenever I log in, my PL/SQL warnings are automatically enabled for all my compilations in that session?
Great question, and there are two answers. If you're using the worksheet like you are, what I would recommend doing is add that alter session command to a login script that executes every time you initialize a connection. So that'll just run for you, and it'll just be ready to go. And then the other option is to use the procedure editor. So if you're running a store procedure from a file or from the database tree, you can set compiler settings in the preferences. Right, so if you run it from here, Steven, if you click on preferences and go to database and PL/SQL compiler, yeah, right there where it says all, that would, I think, do.
Yep, that'll do it. So you can actually, there are different categories of warnings, and you can also even specify, this is pretty neat, you can specify that a particular warning should be considered an error. So I can make 5005 an error in my compilation process. Okay, great. In fact, I'm just going to keep that enabled. Thanks. All right, great question. Okay, but the main thing is to reformat, whoops, let's go back here, to reformat the way you design your functions so that this is not an issue at all. And here's what it would look like. I think I've got an example here. Yes. The basic idea is that instead of returning over and over again, return, 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 declare a local variable, assign the value to that local variable, and then the last statement in my function is return something. It's a very simple refactoring. It's probably something a lot of you already do, but be on the watch for those multiple returns in your executable section. Okay, cruising right along. What's the problem with this code? Jeff, feel free to unmute. Whoever was just speaking, why don't you try speaking again? Call-in user 2 seems to be trying to speak, but I don't hear anything.
Try again.
Please try now. Okay. Well, unmuting doesn't seem to be working too well today. Feel free to write a note in the chat window of your Web Center console, WebEx console, and I'll dive into this code. So what's the problem with this code? It's probably kind of hard to analyze this code, certainly in the 3 seconds I gave you before I asked for feedback, and certainly also difficult out of context of the entire package. So let's take a look at that real quickly. Actually, no, that's right. We should be able to just look at this code and say we have an anti-pattern. So let's take a look at what's going on here. First of all, there's some kind of list of used names in my package that I'm referencing inside my function. I'm passing in a value. I'm getting the total number of rows in my, total number of elements in my list of used names. I'm going to start with the first, and I'm going to set my found flag to false. And while I haven't found anything, and my index hasn't yet reached the count in my collection, I'm going to check to see if I have a match. So I found a match if the value that's being passed in equals the value in my array. And then, of course, I will stop and stop continuing iterating. So what's the problem with this code? Well, the problem with this code is similar to the sort of situation you might find if you were doing a query against a table and that table had no indexes. You would be doing a full table scan. This is potentially a full collection scan. Scan through this array, looking for a match, stop. Well, let's see. If my array has 2 elements in it, I'll go through the array pretty quickly. If my array has 10,000 elements in it, it'll be a lot slower to go through that list of 10,000. And depending on where the match is or if there's no match at all, it could take a lot more time than I'm willing to tolerate in my code, in my application. The other problem is that while this is not a tremendous amount of code, it's a non-trivial amount of code that I had to write. I had to worry about certain kinds of boundary conditions in my looping, make sure I'm not writing an infinite loop, et cetera, et cetera, et cetera. It took some time. It took some effort. Was it necessary? The answer is not at all. Let's see why. So my feeling in general is that you want to avoid full scans of anything in your application. So we know, of course, that full scans of tables are undesirable. And that's true except for maybe in the Exadata world, in which it turns out that indexing can actually slow things down. At least that's what I've been told. Haven't checked it out myself. But for most normal operations that our customers are dealing with, not yet on Exadata, full table scans are to be avoided. Well, so are full collection scans. Now, generally, when you're building your code and writing your algorithms, what you want to aim for are data-neutral algorithms. So, for example, if my table has 10 rows or 1,000,000 rows, the performance of my program stays pretty stable. Or at least if you can't get that, and that's not always possible, then at least what you want to be doing is looking for algorithms that are optimized for your most common scenarios. For example, if I'm doing a bulk insert with for all of 10,000 rows, and I know that usually 9,500 of those rows are going to fail, it actually might be slower to use for all than to do row by row inserting, because for all is optimized for success, not for failures. So when you're doing testing, when you're doing performance analysis, when you're designing your algorithms, think about the range or the different kinds of data scenarios you're going to face and try to aim for the most data neutral algorithm as possible. What does that have to do with all of this? Well, let's take a look. Here's my original package. It's called String Tracker. And I basically keep track of the strings I've used. It's part of a code generation utility I wrote that generates the names of variables for each parameter in my procedure that's being tested. And I don't want to have multiple variables with the same name. That will cause a compile error. So what I've done is created a list of use names, which is a list of strings indexed by integer. And every time I mark a value as used, I simply add it to the list sequentially. And then when I need to see if a string is in use, I iterate through my array looking for a match. This is a fairly typical application of using collections in PL SQL in which I fill things up sequentially. The problem here is that filling up sequentially makes the most sense when the order in which things are added is significant. But the order in which things are added or used here is not significant. The issue, the significance is it in the list or not? So here's what I did to fix that problem. In my next iteration of String Tracker, take a look at my, first of all, my string in use function. Let's get rid of some of the noise around it. Let's see. Actually, that involves more explanation than I should probably get into at this point. Let's do something simpler. That was actually an implementation of the String Tracker package showing support for multiple lists and using nested collections, which is a very cool feature I'm not going to go into today. Here's the simpler version I wanted to show you. So what I've done now is created an array of use names, and it's a table of who cares, indexed by variable name. So first of all, the thing to note is that my variable name is my index. It's a string. So with associative arrays, which means index bys, I can index by strings. Now I have a table of who cares. Who cares is actually a Boolean. Why did I do that? because I'm trying to make my code as self-documenting as possible, and it turns out I don't care what value is in the array. I only care about the index values. It's kind of like an indexed organized table in IoT. So now when I want to mark a string as being used, I take the variable name and I use that as the index value, and I assign doesn't matter, which happens to be a Boolean null. When I want to check to see if a string is in use, I pass in the variable name, and I simply go to that location in my array and ask, does it exist? And I'm done. So goodbye algorithm, goodbye testing boundary conditions, goodbye concerns about whether or not it has 10 or 10,000 elements in the array. Boom, string index collection, use the index for the value that I'm interested in searching on, and I get the answer pretty much the same amount of time no matter how big my collection is. So this, I think, is one of the clearest patterns and use cases for string indexing that you're going to run into. Whenever you see a full collection scan, when you're iterating through the collection looking for something, what you're realizing is that I don't have the right kind of index on my collection. Now, unlike relational tables, I can't add additional indexes. What I can do is re-index, use a collection with a different kind of index, or keep my original collection the same and create separate other collections that are indexes into the main collection, essentially emulating my indexing in relational tables. Either way, what I do is end up with code that is much simpler, trivial in both complexity and verbosity. It's very concise, much easier to manage. So I encourage you to take a look out for those. Okay. So my last anti-pattern, I think the lines are not muted now because I was hearing some noise. So let's find out what you think about this piece of code, and then we'll go into it. Any thoughts? I'm not sure if somebody was just talking or not. Okay. I'm hearing a voice, but it's very fuzzy. Not sure what's going on. My apologies, everybody. Hopefully when I finish and we go to the Q&A, we can get this all cleared up, or you can certainly be writing notes in the chat window. Okay. Whoops. So the problem with this code, and as I'm about to tell you on the next page, it's the #1 anti-pattern of PL SQL, the #1, non-query DML inside a loop. If you ever see a loop, cursor for a loop, numeric for a loop, while loop, simple loop, whatever, and inside of that loop you have one or more non-query DML statements, in other words, inserts, updates, deletes, one or more of them, then what you're seeing here is an incredible opportunity. It's a terrible anti-pattern, but it's also an incredible opportunity because you're looking at a piece of code in which you can have a potentially enormous positive impact on performance. Now, hopefully you're all aware of this. This is all about a new feature a new feature in Oracle added back in Oracle 8i called bulk processing. So that's the anti-pattern, DML statements inside of a loop. Oh, and by the way, I said non-query DML because I'm trying to be more precise in my language now that I'm with Oracle Corporation and working closely with Bryn Llewell and the PL SQL product manager, who is always extremely precise. We often talk about DML, data manipulation language statements, as inserts, updates, and deletes, but that's not really true. DML includes SQL, select statements. So you should really say non-query DML for the DML statements that change the database. Okay, so non-query DML inside a loop, #1 anti-pattern. So it's very elegant and simple, very readable code. I think you'd agree. So we have these native cursor for loops. We can write static or native SQL directly inside PL SQL code. It's a really nice language, closely integrated with SQL. So it's all very elegant. It allows us to define transactions. So in this case, for example, my transaction is insert, then update. And if the insert fails, don't do the update, trap the exception, log it out to my table, and then go on to the next one. So all of this is built into the structure of my PL SQL block. It's really nice. The problem is that I'm doing row-by-row processing. For each one of these DML statements, I'm going to switch from the PL SQL engine out to the SQL engine. It's going to do its thing. It's going to come back and forth and back and forth and back and forth. And context switches are slow, relatively slow, or at least a potential bottleneck in the Oracle database. So the idea is to avoid row-by-row processing and instead switch to bulk collect and for all. Now, this is a topic that can cover a lot of time, easily an hour or two. So I'm not obviously going to go into all the details here, but do check out Practically Perfect PL SQL as I ramp up my performance presentations. Also, if you go to the Learning Library, you'll see right down on this list of events, turbocharge your PL SQL code with bulk processing. And that's a 1-hour webinar. You can watch the recording anytime you like. So what should you do instead? Well, you want to get away from row-by-row processing and move to phased processing. Let's take a look at my solution, and then I'll stop talking altogether, and we'll dive into whatever topics you want to talk about. So first of all, let's go back to my original. Here's my original program. Again, very short, concise, about 30 lines long. Nice, elegant transaction management, and so on and so forth. Then I go to bulk processing. Bulk processing ends up with a program that's 4 times as long, almost 120 lines instead of 30. Much more complex, but you get a big bang for the buck. This is the sort of change you can make in your PL SQL code without going to your DBA, without asking for new indexes or whatever else, and you could see an order of magnitude improvement in performance. Very, very cool. Now, how do you do this? Well, I'm going to switch from my row-by-row processing, in which each record retrieved by my cursor is processed, insert and update, and I'm going to move to a phased approach. Now, in a phased approach, I'm first going to get the next n rows. So when I say fetch bulk collect, I can now get 1, 10, 1,000 rows with a single fetch to the database. So bulk collect is how I improve query performance. And then I get those n number of rows like 100 or 1,000. And then I'm going to do all my inserts. I'm going to do whatever adjustments I need inside my PL SQL arrays, and I'm going to do all my updates. And notice again, I'm using nested subprograms so that I can hide all the details behind a relatively simple statement in my executable section of these are the things I'm going to do. So I do, to remind you, strongly encourage you to use these nested subprograms to make your code very readable. Your main body, your main executable section should be kind of like a table of contents. Do this, then do this, then do this. Now, in terms of insert history, here's my for all statement. So this is how I do high-speed inserts, updates, and deletes. I pretty much put this little header on top of my DML statement. I have an implicit iterator. And somewhere inside my DML statement, at least once, I need to use that iterator with my bind array. So I'm going to take a collection and bind the entire array in. And in this case, I'm saying for all the elements in my employees list, do the insert. And if anything goes wrong, save the exceptions so that I can then iterate through those exceptions and store the information about them. So if I use save exceptions, then Oracle will save the exception information. When it finishes, it will raise the -24381 error, which I've given a name with my pragma exception in it. And then I can iterate through a special pseudo collection called SQL %bulk exceptions. I can log the error by getting the error code out of my array. I can even find out which statement it failed on. Was it the first, the second, the third? And then I face a tricky situation. So I'm going to just cover this one complication, then I'll stop and we'll do Q&A. With my non-bulk approach, in which my single transaction is integrated into a single nested block, I do my insert, then my update. And if anything causes my insert to fail, my update never executes. I need to emulate that same behavior in my for all approach. And in general, whenever you switch from row by row to bulk or phased, you need to make sure that you analyze your transaction and mimic the same behavior at the bulk level. So in this case, Jeff, you might want to mute all lines. It sounds like some people are able to get through to some extent. So what I'm going to do here then is say, well, I'm going to log the error, but I also need to somehow tell my update statement not to do an update for this particular row. And the way I'm going to do that is to take the error index, go from my SQL %bulk exceptions array, and I'm going to delete it from my employees collection. So the data's gone. Now I can't do an update. That's good. Except that my for all statement that I showed you just before said go from 1 to the count of employees. And that assumed that there were no gaps, nothing deleted in that collection. If there are, you get an exception. So I might have removed 1 or more or all of the rows in my employees collection. So now in my update employees, I'm not going to go from 1 to the count. I'm going to take advantage of a really nice feature added in 10G Release 2, which is go for all the indices in the employees collection, but skip over anything that's missing. Just use the ones that are defined. So with this approach, I automatically skip over anything I just deleted, do all my updates. If anything went wrong, save them up, iterate through them, and log the errors. Now, this is a very quick review of the kind of process you have to go through to convert from the row-by-row approach, which is clean and neat and short, to the bulk approach, which can be very clean, it can be very neat, it will be a lot longer, but it will also be a lot faster. So hopefully this will give you a sense of what's possible. Do check out my hour-long presentation and, of course, the Oracle documentation, my books, the blog posts, et cetera, et cetera. But the bottom line, going back to the original motivation for this talk, is watch out for this anti-pattern. Hopefully it's gone from all of your code. And I say hopefully because that means that you've already paid attention to this issue and you've already optimized your code. On the other hand, hopefully it's not all gone in your code because then you have low-hanging fruit. This is one of the easiest optimizations to notice. And while it's not the easiest to fix, it has one of the highest impact fixes of all the different kinds of optimizations and anti-patterns you can look at for PL SQL. To sum up, anti-patterns almost always means you're talking about anti-maintainable code. The more anti-patterns you have in your code, the more widely they're dispersed, the more likely it is that your code's going to be hard to read, hard to debug, and hard to optimize. Now that's bad enough when you wrote the code and you're responsible for maintaining your own code, but it's way worse when you wrote the code and you left the project and years later somebody has to come along and try to understand your code and fix it. So it's a really great thing to build your awareness of patterns in general, the good patterns and the bad patterns, and especially identify those bad patterns in your own code when you're doing code review and be ready to offer the positive pattern to the anti-pattern. And finally, I strongly encourage you to use those compile time warnings so that you can basically have the compiler do as much of the heaviest lifting as possible. Oracle will do an awful lot of work to analyze your code and give you feedback on that code. And just to give you a sense of how much it's going to help you, let's go to Doc. And in case you haven't visited lately, there is a new Oracle Help Center. It's the Oracle Doc, now called Oracle Help Center. And I can drill down into my database documentation. Let's go to all the database books, take a look at the error messages manual. And if you haven't seen this before, Oracle offers information about all the different errors that they've defined. So the standard ORA errors, the PL SQL compile errors are PLS. Are you? There you are. Here are the PL SQL compile errors. And PLW are the PL SQL warnings. And there are a lot of them. Some of them you might find to be kind of a nuisance. They'll keep complaining about how you don't have auth ID, but you don't care. But some of these are really amazingly useful and important, like the operation will raise an exception. So you've got a string that's too long to fit in your container. Boom, at compile time, you can be told about this. So do take advantage of compile time warnings, and you will have a much easier time writing high quality code and identifying areas for improvement. Okay, so it's 11:45 my time at least, and that's the end of my presentation. So I'll put up a little ad for Oracle University as we open it up for questions. So Jeff, unmute those lines. Let's see if we can hear people. And if not, just go ahead and write your question or comments in your chat window. Somebody say something just so we can see if we can hear you. Say, Steven, I loved your presentation. How's that?
Steve, I think you're wonderful, and I'm glad that you're having these sessions, and I wonder where we can find the recorded sessions. I had a hard time getting past the security code.
Okay, so what you can do is go to oracle.com, obviously, go to OTN, and then go to, I'm sorry it's not a little bit cleaner, but I'll just show you the pathway through. Go to Oracle Database, click on Application Development. I'm sure this isn't the fastest way, but anyway. And right here, Webcast Recordings. Join us Wednesday at noon. And then you'll see all the different recordings we've got. And so let me just go ahead and paste this into the chat window. And I think you can all pick up this URL. So you can go ahead and bookmark that one, which I should do as well. Other questions or comments? Any other anti-patterns you've seen that you'd like to share? Such a quiet group. All right. Well, we'll be back next week, or someone will be back next week to talk about other application Oracle database development tools and techniques. Thank you for joining me, and a happy PL SQL coding.
Thank you.
Welcome. Thanks, Steven. Thanks, everyone. This recording will be up later this afternoon, Eastern Time.